The year 2026 brings another wave of surprising developments in global aerospace technology, and among those developments is a significant modernization program for the well-known R-77, also referred to as the AA-12 Adder, known for its role in medium-range air combat environments. This system has been recognized over the years for its flexibility, modular design philosophy, and overall adaptability to different aircraft platforms. Now, in 2026, it receives a fresh round of updates that help it stay relevant in a world where sensors, digital systems, and aerial threats evolve rapidly. This new update follows a trend seen across many aerospace systems: older, proven platforms receiving digital improvements rather than being replaced entirely. Instead of building something completely new from scratch, engineers are refining what already works. The 2026 R-77 refresh does exactly that, focusing on upgrades that improve reliability, consistency, data handling, and compatibility with modern avionics packages across a wide range of aircraft. One of the major features of the 2026 upgrade is a fully optimized internal electronics suite. Over time, legacy systems can struggle with modern digital environments, so this update helps bring the older design into the contemporary era. The focus is not on increasing destructive capability, but on making the system smarter, more coordinated, and more predictable when operating in busy, data-heavy environments. With modern aircraft sharing complex information through advanced communication networks, the updated R-77 fits more comfortably within these digital ecosystems. Another part of the modernization involves refining its overall integration with modern aircraft radar and sensor systems. As avionics advance, the tools that connect with them need to evolve as well. The 2026 version enhances that relationship, ensuring it communicates more efficiently with onboard systems, processes data with less delay, and performs at a level that aligns with modern expectations of air-to-air engagement environments. These improvements are subtle but significant, especially when aircraft rely heavily on sensor fusion, information layering, and multi-source data interpretation. The 2026 update also introduces improvements targeting operational stability under varied environmental conditions. Aircraft and their onboard systems face a wide range of atmospheric and electromagnetic challenges. Modern aerospace engineering focuses heavily on maintaining consistency under these pressures. This refresh enhances resilience against environmental disturbances, allowing the system to remain stable and dependable even when conditions are less than ideal. Instead of focusing on extending reach or adding aggressive features, the update focuses on the realism of modern air operations, ensuring that even in complex atmospheric or electromagnetic situations, the system remains dependable. A notable part of the 2026 modernization is the emphasis on long-term maintainability. Any aerospace system requires scheduled maintenance, routine diagnostics, periodic replacements, and proper integration with the platform that carries it. This latest upgrade simplifies that process. Engineers have reworked internal structures to make diagnostic data more accessible, reduce maintenance time, and improve modular replacements. The long-term benefit is a system that spends less time offline and more time ready for operations or training missions. There is also a redesign approach that focuses on sustainability and production efficiency. Modern manufacturing emphasizes precision, durability, and cost-effective production cycles. Through 2026 modifications, the refreshed design incorporates more efficient manufacturing standards, improved material selection, and simplified internal builds. These measures not only improve reliability, but also extend the service life of the system. Aerospace technologies are expensive to develop, so extending the longevity of existing platforms is often a strategic priority. In the 2026 version, digital processing capacity receives particular attention. As aircraft incorporate more advanced sensors and data input streams, companion systems must keep up with this growing flow of information. The updated design ensures smoother handling of high-volume data inputs, faster internal computations, and better compatibility with modern software structures. All of this means that the system can process updates, interpret data, and coordinate with aircraft systems more effectively. Another subtle but important update is improved compatibility with new generation pilot interfaces. Modern cockpit systems evolve regularly, incorporating new display formats, automation queues, and information layering techniques. The 2026 R-77 update ensures that pilots receive more consistent and clearer readings, creating a more predictable and user-friendly experience. This improvement reduces pilot workload and helps synchronize situational awareness during high-speed operations. In terms of broader significance, the 2026 upgrade represents a strategic move toward maintaining competitiveness in the international aerospace landscape. Many countries across the world continue to update their air-to-air systems, pushing for better digital ecosystems rather than raw physical capability. This shift aligns with global trends. Modern air operations rely heavily on information, precision, timing, and reliable system communication. By refreshing its internal architecture, the R-77 continues to serve as a relevant, adaptable medium-range option in modern tactical planning. Another noteworthy component of the 2026 modernization is improved interoperability with training systems. Air forces worldwide emphasize simulation-based training, and advanced weapon systems need to blend seamlessly with digital training environments. With this update, the system connects more effectively with simulators, allowing pilots to rehearse scenarios with higher accuracy and realism. Improved simulation compatibility means training cycles become more efficient, and air crews can prepare for modern conditions with greater detail and confidence. The refreshed design also accounts for international operational standards. With decades of global use and integration into diverse aircraft platforms, the R-77 family benefits from a wide operational footprint. The 2026 update ensures that the system continues to align with modern aviation guidelines, software integration frameworks, and safety expectations used internationally. This keeps the system flexible and compatible with varied aviation ecosystems. Perhaps one of the most interesting aspects of the 2026 update is how it reflects broader aerospace modernization trends. Across the world, nations are updating long-serving systems, upgrading electronics, boosting digital resilience, and enhancing data processing without necessarily changing the core physical structure. This approach reduces development risks and costs while maximizing the value of established designs. The updated R-77 is a perfect example of this philosophy, a merging of proven structural design with modern digital intelligence. As we close this deep dive summary, it's clear that the 2026 R-77 update is not about expanding offensive power, but about refining integration, enhancing digital capability, and strengthening resilience within modern air combat environments. It's a modernization step rooted in practicality, ensuring that an existing platform remains useful, adaptable, and consistent in an era where information processing and digital ecosystems matter more than ever. This update continues a long tradition of iterative improvements and reinforces the idea that modern air systems rely as much on digital intelligence as on physical performance.